Hi everyone. Hi everyone on the audience on the GDC, and my name is Lou, and I'm a software engineer at Google. This spring, I had the amazing opportunity to work with Avianna. Avianna is an eighth grader here at GMS. The first time I met her, she has a real passion for social impact. A lot of things we talk about, including climate change or preventing wildfires. So one of the projects she did for this spring was AI coral identifier, beginning with identify types of coral before considering conservation strategies for those corals. Yeah, it has been just amazing working with you, Avianna, and I have been amazed at your ability to ramp up so quickly on Python and machine learning concepts. And with that, I now present to you, Avianna.
Hi everyone, like we said, I'm Avianna and I'm the Next. So now I want to introduce my mentor. Her name is Lou, and she was an awesome teacher and guide. She's worked at Google for 10 years, and now she does AI, specifically in healthcare large language models for Google search. She's originally from Shanghai, China, and her hobbies include reading, yoga, and playing with her corgi bedtime. It's been an amazing experience to work with her. Next. My project identifies the types of coral that are in images. So I wanted to do this project because I care about climate change and I have a special interest in coral. Even when I was younger, I had this interest. Like when I was 10, I asked my friends to donate to a coral organization instead of giving presents. And through this experience, I've learned to code more Python, and I've learned a lot about how machine learning models are built. Next. So how I picked my project, I really wanted to make an impact on climate change. So some of my ideas included a restaurant or supermarket food share app so that companies can limit food waste, or a wildfire predictor that warns where wildfires might start. And of course, what I chose to build, a coral image. So originally, I reached out to multiple organizations to make something that would be used in the real world. Unfortunately, it took a lot of time to coordinate, so I had to move forward. I'm still in conversation with one group, so we'll see what happens. Initially, I kept the product simple by only trying to classify two types of coral, healthy and bleached. And I built off an image classifier lessons model. After I was able to successfully train a model with two types, I tweaked the code to include multiple classes. Next. Some of my highlights include the Google tour. So I went to the Bayview campus and I got to see the building architecture, and Lou shared what it was like to work as an engineer. And I learned about machine learning and what it's like. And I was really surprised to learn that machine learning involves running experiments to observe what the model would do, almost like predicting how an organism behaves. Some of the challenges I faced were the model accuracy. So at first I couldn't get the model to predict the images right, and also learning Python and finding good quality data. Next. So some of the lessons I learned, grit. There's a lot of trial and error with writing the code and testing it out to see if it'll work. Sometimes it got really frustrating when the model was not learning to predict the images right. But with the help of my mentor, it was really rewarding, and when I got to see the final result. And then things I learned about machine learning are the difference between a big and small model and when to use them. So a big model, you use it when the images are higher quality because it tends to overcomplicate lower quality images, and it's the opposite for a small model. And next. So here you can see some of my dataset images. So I labeled different classes of coral, and the image quality of these were lower, so I used a smaller model. And then I also learned how to improve model performance, which I'll talk about next. You have to unmute it. It's unmuted.
Avianna, can you voice over?
Can you just speak over?
Yeah.
No.
They need to share the speaker from their computer for this to have sound. So just unmuting it so it cannot work that.
I don't have the.
Yeah, I'll have to stop it. You describe what you're
Maybe
saying.
describing.
Okay, well, basically, it's like how to understand how a model works. So like to think about how you are like a birder and you need tools like binoculars, and then you need data like good birds. And then you kind of learn to identify birds better by like looking at the features. So some have long beaks, some are larger, some have different color patterns. And then you put together these features to identify the type of bird it is. The more you practice, the better you get. Okay, and then this is my setup code. So it's like basically importing all the tools like the binoculars. This is my data, which is like the birds. This is the pre-trained base, which the base is basically something that picks out the features. And then the head puts them together to identify the classes. And then in training, it's basically does it over and over again to try to get it right. And then it runs for multiple rounds. So an epoch is where you see all the images at once. So that one runs for 60. And then I wrote this code to save the best model, which is the epoch with the highest accuracy. Okay, next. Oh, great. Okay, then I would run the training model so it'd be easier to classify coral, which I didn't include in the demo because each run would take a while, anywhere from 5 to 60 minutes, and it isn't very exciting. As the model progresses, makes progress, it would add a number each time it completed one of the 60 epochs, and that's how I know it would still work. And then after model completed a round, it would determine how well the training model classifies images by using a second set of data called validation data set, which I'll show next. So that's it. So after the model is done training, it produces 2 graphs comparing the training data set against the validation data set. This first one shows the loss, which is how wrong the model is, and the blue line is the training data, and the orange is the validation. Generally, these dry lines track each other, but the goal is to have the lowest number possible, which shows that the model is not getting the predictions wrong. And then the second one shows the accuracy, which is how right the model is. Here, the goal is to have the highest number possible, which means that the model is predicting the coral images right. Next. So a lot of the work used graphs to improve the accuracy. So this left one, the early model, is the initial one, and it's kind of hard to see, but if you look at the scale on the y-axis, the accuracy was around 22%, which wasn't very good, so I tried some things like adding more epochs, adding augmentation, which basically changes the data so the model can see different things, and then I changed the model base. And then the final result that I got was the accuracy was 86%, which I didn't think was too good, but Luke told me that it's a high level of accuracy, especially for my experience. In 3 short months, I've learned so much, and Magic has been an incredible experience that taught me a career in AI. Involves prediction, observation, intuition, and lots of patience. Next, thank you.
Wonderful presentation, Avianna. Do we have any questions from the audience?
See, one question. When you were doing a model training, were you running it locally on your machine, or were you using some cloud instance where the LLM is also accessible?
So the question was if I'm running the model locally or like in the cloud. I think it's locally, but it's I did it on this website called Kaggle, but it basically has models accessible to you, and then you can run it. Oh, it's on the cloud. Yeah.
Can you explain to the audience the difference between a large model versus a small model? And you also mentioned the quality of the image was less, a detail less resolution, and that impacted which model you selected.
Yeah, so the question was the difference between a large model and a small model and the images. So a large model has like more layers, so it like analyzes the pictures deeply, and then a smaller model has less layers. So initially for these lower quality images, I was using a bigger model, which had the lower accuracy, as you could see from the graph. But when I switched to a smaller model, the accuracy improved a lot because the larger model was overcomplicated.
Yeah.
Yeah.
Also, at some point, do you have to actually provide the validation to the accuracy of your data? Because you said you run several iterations, and I imagine the validation doesn't necessarily come to you. Do you have any kind of a human interpretation intervention to correct accuracy?
Yeah, so the question was about the validation data set and the accuracy. So I collected images, I downloaded images, and then I split them up into training and validation. So the training data set had more images than the validation, and it would load both onto the code, and then when it ran, it would run both. Yeah.
So you mentioned that you were reaching out to some organizations about using this, and whether that's been successful or not, like that's really hard. I'm curious how you pitch this idea to an organization. How do you envision this model getting used out to make change in the world?
Yeah, so the question was about how I would use the model to make a change in the world. So when I first reached out, I wanted to see if they had any ideas for me. But since it was like too hard to partner, I just chose to go with coral types. But from one of the coral websites that I saw, it was like using the type, like different conservation strategies for the types of coral. So I was thinking if the model could predict the types of coral that it was, then it can use the types of coral to identify a conservation strategy that works best.
Yeah. How did you know all the types of corals? Did you have to annotate the data yourself and find out which image was what type?
Yeah, so the question was about how I annotated the images. So I used this website called coral.net, which had all the images in categories already. So I would just download them and then put them into folders and manually organize it on my computer. And then it would all upload to Kaggle, which had it already.
And do we have any questions from our virtual audience?
Hi, I have a question. This is Smriti. Fantastic job. I guess a comment and a question. The comment being, I'm so wowed by your ability to kind of explain the inner workings of AI, and like I loved the demo video you had, and I hope that along with whatever you do on the side with the coral, that you maybe share that on YouTube or something. I feel like it would make these things more accessible to beginners, and it seemed like you explained those things really well, so thank you for that. The question I had was also related to data sets, but I'll ask a slightly different question, which is how many images did you have to use? Did you notice anything about if you added more images, took away images, things like that?
Yeah, so I had about 500 images for my training data and then about 60 for my validation. But I think the more images, the better. So usually models have like thousands and thousands of images, but I had to manually download them individually. So I didn't have as many.
And how did you choose the validation set?
I just, out of the pictures that I picked, I randomly selected like a group of them and then put it in a different.
Very cool. Thank you.
Wonderful. Any last questions for Avianna?